it started automatically. I think I am using the same computer.
Yeah.
So.
I see.
Okay.
Live ho gaya?
Yeah. I think it is. Is it live? Someone can check.
Yeah.
Okay. So good afternoon, everybody. Can someone confirm me that?
Your screen is visible, sir.
Yeah, it is visible.
No, is it streaming in the YouTube or not?
I don't see yet, but let me confirm once again.
But according to Zoom, it is already streamed.
Still. Yeah, it is coming in YouTube.
No, is it streaming in the
Yes,
YouTube or not?
It is streaming on the YouTube.
Okay, so
Yes,
let's
now it is.
yeah. Okay, so let's start. Yeah.
I
So
don't
good.
see yet.
I think it has been started. Okay, so let's start. Zoom, it is already streamed.
Still.
Yeah, it is coming. No, is it streaming in the YouTube or not?
It is streaming on the YouTube.
So
Yes.
please mute others. Yeah.
Just one second.
Yeah.
Let me mute the.
So good.
Okay. Now go ahead.
Yeah. Good afternoon, everyone. So the last week we have inaugurated that's online satellite meteorology course. So today our chairman for the satellite meteorology, Dr. R.C. Bhatia, he will introduce us the overview of satellite meteorology and its application. For this, I welcome Professor Sameshwar Das, Secretary Sama, to say something about the course and for our vision.
Okay, thank you, Swagata. ABM Professor Tyagi Saab, President of SAMA. Professor Kelkar Saab, Dr. Bhatia Saab, the speaker of today, the members of the advisory panel, organizing committee, and all the registered participants. We welcome you on behalf of the South Asian Meteorological Association and the BIT Birla Institute of Technology for this second lecture of the lecture series on satellite meteorology. During the last 1 week, we see that about 100 more people have registered for the course. Last week, about 1,600 people had registered, and as in today, it is more than 1,700 people. So I'd like to repeat once again some of the points which the new people could not attend last week. This is our third attempt on the capacity building of the people of South Asia, and also the countries of the member institutional member countries like NAM, SMT, RIMES, and EC mode. As I mentioned last time, we have got registrations from more than 80 countries, although SAMA has only 9 countries, but the other countries are basically the members of NAM, SMT, RIMES, etc. So we welcome you all. This is the third lecture series, which will go on for 20 weeks. We started last week. The first lecture series was conducted on atmospheric physics this year from 7th of January till April for 4 months. And the second training program was on the WRF modeling system, which also was conducted, I think, between 3rd of April and 24th of April, and it had hands-on training also on the computer of CDAC, Center for Development of Advanced Computing. The first lecture series was jointly organized by the SRM Institute of Science and Technology, Chennai. The second one was jointly organized by CDAC, and the third one, that is today, is ongoing, is being organized jointly with the Birla Institute of Science and Technology. As we mentioned last time, this lecture series is basically designed based upon the request, or the syllabus of this lecture series is designed based on the request and feedback from the member countries. The speakers of this lecture series are very distinguished people. Many of them, or most of them, are themselves scientists or professors emeritus in different universities in India. And the lecture series is meant for basically the postgraduate students, the researchers, and also those who may not be having a direct background of meteorology, but maybe from physics or mathematics, but may be interested in learning meteorology. So this lecture series is intended for them. As we mentioned last time, that at the end of the lecture series, we shall provide certificates to all those participants who will have at least 75% of the attendance. But those who want certificate also, some sort of grade certificate, like whether they could get an outstanding or excellent, etc., then they will have to appear in a test, which will be conducted at the end of the lecture series. And there will be a small fee for that, which will be announced later. So with this brief background, I would like to welcome you once again and enjoy the lecture. Have a good time. On to you, Dr. Swagata.
Thanks a lot for this very warm welcome. Now, I would like to invite our president of the SAMA, ABM, Professor Ajit Tyagi sir. Sir, stage is yours now. Please say something about our online lecture series.
Thank you, Swagata, and I join Somesh for welcoming all our distinguished speakers, Bhatia Sahab, our esteemed guide, and the distinguished participants to this series of the lectures. I'm really happy and thankful to our Satellite Met committee led by Bhatia Sahab for having planned this lecture series, which is third in our lecture series being organized by SAMA, based on the feedback received from the member countries and the response which we have received, reaching 1,700 registrations, which shows interest in this particular subject. So it is very encouraging, and I'm sure through our online lectures and the YouTube channel on which it is being recorded, it will benefit a larger community. Satellite meteorology, especially after you see the launch of Chandrayaan and solar mission satellite, has created much more interest in the general public, and I'm sure it will also lead to the interest in the satellite meteorology, which somehow has not been to the extent in which it should have been there, because satellite meteorology has got a wide application, as I told you in my last inaugural address also. Almost all socio-economic sectors, from agriculture to energy to the aviation, shipping, you name, and hydrology, it has got this implication, and also the science part of it, the multidisciplinary science which it is able to generate. So it has got a lot of potential both for academic community, those who are engaged in the research, and also the user sectors. And this lecture series has been designed keeping all these requirements in mind. We have eminent speakers who will be covering the basics of the remote sensing, then the various products which are being generated by a variety of satellites which are available, and their application, particularly in the meteorology and the forecasting. So it will have an overview of all aspects related to the satellite meteorology, the science of it, the products which are available, and the applications which can be done and are being done. And we also would like to, in the course of this particular series of lecture, will interact with the IMD, MOSDAC, NRSC, one, to see that the data which is being generated by these agencies is how do we make this available to the students, to the researchers, because that is a great demand, but somehow there is a communication gap between the agencies and the user community. So I urge SAMA to use this platform also along with the providing training as a link for providing the data and the products which are available, which can be used for research and also for the applications. I'm really thankful to Bhatia Saab, who has led this initiative. I have known him right when I was in the Air Force, then the IMD, and post-retirement. He is among very few of our professionals who continues to take keen interest and support various capacity building program organized by various agencies in the country. So thank you, Bhatia Saab, for leading this program of the SAMA, and welcome to this lecture. I am sure your introductory lecture, after two very important lectures given by Kelkar Saab and Dr. Raj Kumar in the inaugural session, this will be another very important and useful lectures for the participants. Thank you.
Thank you, sir. Thanks a lot. And I'm sure that SAMA will progress in which way you are just expecting, and your guidance are there. So we'll continue our growth, especially related to outreaching of that subject, our own subject. So now I invite Dr. Fatima Akhtar, Chairman, Department of Meteorology, Dhaka University, and also very much active member of SAMA Bangladesh chapter. So, ma'am, it's up to you now. So, please introduce. You could share the slide.
Thank you for giving me the opportunity. Am I audible?
Yes, ma'am. Yes, we can see the introductory slide. Yeah.
Visible?
Yes, ma'am. You can go to the full view mode.
Thank you.
Yeah, this is fine. Ma'am, your volume.
Regional Director of IMD, New Delhi, India. Sri Ramesh Chandra Bhatia, sir, served India Meteorological Department and retired as additional. Can you hear me?
There is a network problem, probably.
Yeah.
Can I?
And your voice is breaking.
Yeah, your voice is breaking, maybe due to internet.
Oh,
Yeah.
sorry.
You can try to switch off the video and introduce. It may help.
Yes, ma'am. You can switch up your video. Yeah, then carry on.
Am I audible?
Yeah.
Yes, ma'am.
Yes.
Thank you. I'm introducing our today's speaker, Sri Ramesh Chandra Bhatia. Sir is the former director, additional director of India Meteorological Department, New Delhi, India. He served as 36 years and retired as Additional Director General in December 2008. He has played a leading role in planning for overall modernization program of IMD during the period of 2006 to 2008. This program has proved to be a game changer for IMD. A large positive impact of this program has been observed on various services being provided by IMD for all sectors of national economy, particularly on the cyclone warning services. Dr. Bhatia was permanent representative of India with the WMO and has elected as a member of the Executive Council during 15th session of WMO Congress in 2007. After undergoing training in satellite meteorology in CEMS, Lannion, France during 1977, he has been very actively involved in the INSAT Meteorological Applications Program of Government of India. He has also played a leading role in planning for all INSAT series of satellites and established a ground segment facilities for the Meteorological Applications Program of these satellites right from the early stages of the inception. Dr. Bhatia participated in many international and national meetings and conferences related to satellite activities. He has published more than 50 research papers in various journals and proceedings of conferences. As in charge of instrumentation and telecommunication activities for a few years, he has made significant contributions in establishment of Doppler weather radar network in the department. His contributions are also important for improving the quality of radio sound observations, automatic weather stations, and establishing new type of instruments at airport meteorological offices. At present, Dr. Bhatia is engaged in review of some of the research papers sent by the editorial board of journal MSET and delivering lectures on satellite meteorology in some of the training courses of IMD and ISRO. He was also president of the Indian Meteorological Society during 2007 to 2009 and participated in the first two meetings of IFMS. Thank you. These are the information for a small introduction of our today's speaker. Thank you.
Thank you, Dr. Fatima. So before starting the lecture, I recall one sentence in the book of satellite meteorology that until the invention of hot air balloons in 1792, the only way humans could get a bird eye view of the earth was to climb a tree or hike to the top of a mountain. So by that, I think I invite Dr. R.C. Bhatia sir for the overview of satellite meteorology and its applications. Mohan, I think, yeah. So, sir, now you can share your slide.
Okay. Can you see my slide now?
No, sir.
I've shared screen.
Why?
I've shared screen. Can you see my screen?
No,
Not
sir.
yet.
Can you just come?
Yet.
Can you see it now?
Yeah, it is coming. It is coming.
Okay.
It is coming. Yes, sir. The screen.
Okay.
Yeah, we can see the screen now. I think if
You can see full view.
still not, but you can do that full view. Sir, press F5. Sir, F5, press F5. And also record has been stopped by somehow. So who is taking care of that? Please start the recording. Sir, you press F5.
I press F5.
F5.
Slow in response.
F5 I pressed.
So first you click to the your slide and then press F5. Yeah. Then you press F5.
It's coming.
No. Click in the right side. Yeah. So little below. So little below. Bring your sir, cancel. Sir, cancel the screen. Yeah, and keep that mouse there. Click once more over there. Here.
Here.
No. Below. Yeah, click here and press F5. No, not there, sir.
Huh? Where?
Here. No.
Here?
In your right side. Yeah, in your slide itself. Click here, and then you press F5. F5.
Yeah, F5.
Okay. Otherwise you come down and
F5.
yeah. Otherwise you go below and bring below and little right side there is a icon. At
Here?
little right side. Yeah.
Up like icon.
Huh?
Otherwise, if there is no animation,
one
we can
minute,
go like this. If there is no animation, we can go like.
One minute.
Sir, otherwise, if you can send us the slide.
I'm coming. I think it will come. Can you see my screen now?
Not yet, sir.
Not yet.
अभी तक नहीं.
Okay. Now
We are
It is coming. It is coming.
it's coming. Okay.
वो पीपीटी वाले पे रेड कलर का जो पी है उस पे प्लीज प्रेस कीजिएगा सर.
कौन सा?
सर नीचे वहाँ पे पी लिखा हुआ है जहाँ पे प्रेजेंटेशन है पीपीटी रेड में नीचे है ना शायद उसमें आपका प्रेजेंटेशन.
हाँ ये इसी ने किया है मैंने.
एकदम लेफ्ट साइड वाले में क्लिक करिए.
इसी ने किया है.
और इसको यहाँ पे जो राइट हैंड कॉर्नर में एक स्क्वायर है ना उसको आप प्रेस कीजिए शायद तो वो ऊपर आ जाएगा. वो नीचे चला गया.
राइट
ये
हैंड कॉर्नर में एक स्क्वायर टाइप का बना हुआ है कॉर्नर के
ऊपर वो
साइड।
अब ये
हाँ हाँ यहाँ पे
फोटो आ
क्लिक
रहा है,
कीजिए।
इसके
और थोड़ा
ऊपर
सा
ना ये फोटो आ रहा है।
और थोड़ा सा लेफ्ट
एक
पे
मिनट,
क्लिक
वो
एक मिनट।
मूव नहीं हो
हाँ,
रहा।
अभी 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 आ जाएगा।
जी जी, इसको हाँ उसको प्रेस कीजिए, डबल टैप कीजिए जी। और अभी नीचे में जहाँ पे ये आपको स्लाइडर दिख रहा होगा, राइट हैंड कॉर्नर नीचे में, हाँ
अभी
हो
आ
गया,
गया।
परफेक्ट
noise.
हो गया
Okay now.
जी।
Yes. Go ahead.
क्या हो गया?
तो फिर
स्टॉप हो गया सर, फिर से प्लीज दोबारा से शेयर कीजिएगा।
नहीं, वो दूसरे पे प्रेस कर दिया मैंने, स्टॉप शेयरिंग कर दिया शायद बाई मिस्टेक।
जी सर, कोई नहीं, आप फिर से एक बार ट्राई।
क्या हो गया? अभी कहाँ है?
Oh God.
एक मिनट।
Anyways, some participants are still joining.
ओके,
I see that it has increased to 247, 248. So
जी सर आ गया। और वो डबल टैप कीजिए, हाँ वो नीचे स्लाइडर में राइट हैंड कॉर्नर में जो एक 86% वगैरह लिखा हुआ है, उसके साइड में देखिए, लेफ्ट साइड में एक स्क्वायर बोर्ड जैसा है, उस पे टैप करने पे भी स्क्रीन बड़ा हो जाता है, मतलब फुल स्क्रीन हो
इसके
जाता है।
यहाँ पे
उसके पास, उसके लेफ्ट हैंड साइड में जाइए, जो नेक्स्ट आइकन है
left.
लेफ्ट हैंड में थोड़ा सा
इधर
जाके, हाँ
इधर
उसके पास, हाँ उसके नेक्स्ट टू दैट।
यहाँ
यस जी
Yes.
सर, जी सर, जी
इसके
सर,
टैप
जी
कर
सर,
क्लिक कीजिए उस पे क्लिक।
जी सर, इस पे
दिया।
क्लिक करने पे
हाँ ठीक है आ गया।
And now this is perfectly fine.
Is it moving?
Yeah, yeah.
Please go ahead.
It is perfectly fine. Yes.
Okay,
यस सर, इट्स मूव।
Yeah, now you can start.
okay,
So, okay. So,
okay.
all
You are
other
giving
participants.
45 minutes. 45
Yeah.
minutes.
Yes, sir. Yes, sir.
Okay. I request that after 30 minutes, just remind so that I can wind up in next 15 minutes.
Okay, sir. I will do.
Thank you. Okay. Good afternoon. The contents of my presentation I have just put here to give introduction. I give brief summary of developments in past 63 years and main systems available over India for use, and features of images and products over India and surrounding areas, and some examples of specific use in certain situations. Future programs summary. Now, in any weather forecasting survey, there are some important steps, as you know. First is observation, then analysis of present state and prediction of future state using numerical weather prediction model. This we do every day. And then issuing inference bulletins, advisories for users. And then testing. Testing means seeing how good your forecast was. Suppose if you issued yesterday some forecast, next day will come before you and you will know whether your forecast was correct or not. So testing we are doing every day. So very strong R&D support is required for all the above activities so that you continuously make improvements in the services. Now when I talk of observation, you know there are many types of observation: conventional, upper air, aircraft, ships, and so on. And we will be talking about this space-based system which is put here in this area. And there are others, of course this is most important part of the observation system. And when you talk of analysis, this is just one sample which I've shown here. It indicates some winds at 850 HPA, and similarly you can have analysis for other altitudes, 700, so on. And this is just one parameter. Similar to that, there are many parameters for which you do the analysis using computers. Finding the initial state of the atmosphere with observation, and then predicting future state using NWP. And after doing everything, what you find is a product of this type, say rainfall assessment for say 24 hours or 48 hours. And depending on this, you give the forecast, you issue bulletin, inference, everything. And now, why space-based systems are important? Because you require observation over very big area with high resolution. Extent and detail is the key word in this. You require observation extent-wise and area-wise in detail. And once having issued a forecast, there is a need to observe how weather systems of different spatial scales are evolving with time. And so it is necessary to update, modify forecasts suitably using real-time monitoring of weather system using latest observations or data. And verification of the forecast issued is also required, as I mentioned some time back. And satellite-based systems, they provide most useful input for all the above stages. They are useful for all these 4 stages. And when I talk of area-wise, coverage-wise, you see this is the map. You need observation over the entire Earth, right from North Pole, South Pole, East to West. Entire Earth needs to be covered. You see this is just one sample of total terrestrial water vapor, and how frequently it is getting updated every hour. And this is just one parameter. Similar to that, there are many other parameters for which you need observation. So this is the type of coverage you need for day-to-day weather forecasting. And there have been some major changes in weather forecasting services. As per old system, we were just giving the forecast and disseminating through TV, radio, print media, etc. But now things have changed. As you know, the general awareness of public has increased considerably, and there are a number of users. There is a wide variety of users, and forecast is useful in many sectors of national economy of different types, agriculture, aviation, and so on. You know all these areas. And it is impact-based forecast which is now being issued. And most important thing is based on the forecast and advisories given by IMD and other forecasting services everywhere in the world. Actions are being taken by the user. Many users, they are taking a lot of actions. So forecast, they have faith in what you are saying. So therefore, now there is a even better need to give useful services, even improve forecast, more focused, so that they can make proper use of the information. Now, how MET satellites have evolved, let us say from, as it was mentioned other day also by Dr. Gilgar, Tyros 1, the first April 1960, that's the most important day when the pictures of Earth cloud covered by Vidicon cameras, they were transmitted by Tyros 1, and it was followed by 8 more such satellites, 60 to 65. And see, whenever you start something new and you want to make improvements in that, there is a need for R&D program. You must start R&D immediately. So R&D program was started by NASA by launch of Nimbus and from 1964. Now main purpose was to prove as a test bed for new instrument so that you get experience in operating instrument and using them. So this was followed by 7 or 8 more satellites up to 1979. And these days, whatever new instrument you are seeing, SSMI, MSU, and so on, which have got good impact, they were all tried on Nimbus series of satellites from 1960s and early 1970s. So based on this testing, based on their experience, they are now working fine on the present systems. So after that, there was ESA series of satellites, ESA 1 to 9, improved Tyros operational satellites or ESA satellites from 1 to 9 in mid 60s to mid 70s. And this was again powered by improved TIROS operational satellites, a NOAA series of satellites, pictures of Earth's cloud cover in visible and infrared band. So this is the first time radiometer was put, and we started getting picture in the infrared also, in addition to visible picture which we were getting prior to that. And they were started in early 1970s and continued in 1990s and even beyond. And some satellites of this NOAA series are even operating now. And this is the ATS satellite, just the Vidicon camera. You can see very simple at that time. And Nimbus, of course, since it has to be R&D and it has to carry many more instruments, it has to be bigger system. So this is Nimbus spacecraft. And ESA, again very simple system, Vidicon cameras only. And there were some improvements done on NOAA series of satellites from time to time. And one I can count, it was NOAA from TIROS 10, NOAA 5, 78, 79. A number of channels were increased. And another from NOAA KLM series, that is NOAA 15 onward from 1996. And in that, microwave instrument of improved specification was added, MSU, which we hear these days. It was started from at that time. And immediate improvement of that, it was found as an important result that the upper tropospheric warm core anomaly in a tropical cyclone, which was of the order of 16 degrees at that time, it was found in a paper by Kidder et al. In BEMS, June 2000. So immediately after giving new things, there were improvements in the understanding. Therefore, they were continued in future. And reception of picture from orbiting satellite in India and started in see, in these satellites there is a, what is called Automatic Picture Transmission Facility, APT, 1962 it started. And under International Indian Ocean Expedition Program, we got an equipment which operated at Bombay from December 63. It was given by US National Science Foundation. And of course, in addition to this, indigenous equipment was made at New Delhi and Madras 1971, and they were started, and we started more stations in IMD from 75, and they continued to operate till 1983-84. At that time, for reception of, this is for reception of APT picture, just visible infrared. And on NOAA series of satellites, there is another important capability, what we call high resolution picture transmission. So this equipment was also started at IMD in 81-82 for reception of high resolution pictures from NOAA series of spacecraft. And now a new system was installed in 2000. And another such system was installed in Chennai from 1996. And in these, once these systems were added, a lot of research was done. In fact, particularly Dr. R. Suresh, he had some papers. He was working in Chennai. He had some papers on using cross data, and he found some interesting results for cyclone movement using cross data. Now, in addition to NOAA series, there were some DMSP, Defense Meteorological Satellite Programs of USA, and focus was on microwave and lightning detection from space. And some satellites of this series are even operational now. And there was research and development program under EOS, Earth Observation System. And of course, later was named. So this was, I think, a replacement for Nimbus program. So the R&D continued. And there was some NPOS program in which the capabilities of NOAA and DMSP were combined together to get a single spacecraft, a single program, what we call NPOS. And under this, the first satellite, what called SOMI NPP, has been started from 2010, and it was followed by next satellite of the series, and many more will be planned for next few years. And then under the WWW program of WMO, a number of geostationary missions have been started from 1970 onwards, And of course, this is image of DMST. You can see it's a bigger system as compared to Vidicon cameras of Tyros and so on. And under geostationary program, there were other systems by Europe, USA, China, Russian Federation, India INSET system. I will come to that in few minutes. And later on, Korea also started this activity. And some polar orbiting satellites also available from Europe, the METOP series current, China F1 series, Russian Federation, Japan, India, OceanSat series particularly, about which Dr. Rajkumar talked other day, megatropics and so on, OceanSat series. They were useful for some of the weather forecasting applications. And just if I want to give a summary of progress made in 63 years, I can say that the imaging radiometer improved from just 2 to 3 channel to multi-channel. That is, say example, 16 channel for GOES ABI, FCI on MTG, Meteor Set third generation. This is a new instrument which has been started by European agency in December 22, and 36 channels on MODIS. You are aware of it, many people know about MODIS. It has got many channels, and there is more frequent imaging every 10 minutes now instead of twice a day, which was when we started, and every 1 minute sector can also be given from GOES. Sounders, they improved from 7 channels to 20 channels and now to 4,000 and 8,000 channels, infrared hyperspectral channels. So this is a major improvement. A single imaging instrument to more instruments of different types, and resolution of instrument improved from 4 kilometer or 8 kilometer to 0.5 or 1 or 4 kilometer. So because of so many improvements, data has increased considerably. And of course, microwave bands have also now been started. They are also, it's possible to use data from microwave bands, both active and passive. And somebody will talk about the microwave remote sensing and black and white color images to RGB products. Now, because of many channels, you can combine them in a number of ways so that a particular feature is brought out in certain image of weather system. Say convection you want to see or air mass you want to see, you can use RGB products to bring out certain features. And of course, there were a lot of experimental proof of concept missions which were started. For instance, Aquaterra under US program, TRIM, NASA Japan mission for rain monitoring over tropics, GPM mission it is for monitoring precipitation, then soil moisture mission, atmospheric pollution, then most important, most recent atmospheric dynamic mission, a 3-dimensional wind radar for 3-dimensional winds measurements from space. And this mission has now ended. It started from 2018 to 2023, and for the first time 3D winds are available. So this is example of microwave imaging. So now for a tropical cyclone, this type of images are there on the website of Wisconsin, where one can track tropical cyclone and see a lot of product. This is one mic, so you can see rain bands around a tropical cyclone and how it is moving. So information is there on the website. Of course, TRIM, I mentioned, it contained a precipitation radar. It provided very useful data for 17 years, and it ended in 2015. GPM, of course, it's a new thing. It started from 2014. Again, it has two radar, Ka-band radar and Ku-band radar. Ka-band is new addition, so better precipitation estimates, and the 3D wind mission, which I was talking few minutes back, this has ended and provided a lot of useful information. It has got good impact on the wind forecast. There are some reports on the website of improvements in the NWP. Of course, there are other systems, Cloud Set, Callisto, for three-dimensional, the vertical structure of the clouds. And of course, there is a particular, what they call A train, where a number of missions view same area at different times. They come one after the other, and so that they provide useful data for research purposes. Of course, there are 4 such satellites at present, and of course, I need not explain geostationary and polar orbit. Everybody knows about it. Now, INSET system, it came as a result of policy decision of Government of India in 1975, and it was for 3 services: telecommunication, TV, and MET. And under this program, to start with, we had 4 satellites, INSET 1A, B, C, and D, but they were procured from Ford Aerospace Company, FACC. It stands for Ford Aerospace Communication Corporation of USA, and they worked from 82 to 2002. Out of these, 1B and 1D, they worked for more than 10 years, but 1A, it didn't work for more than 3 or 4 months. I think in September 82, it stopped working, and 1C also stopped working after 1.5 years. But in spite of that, 1B, 1D, they provided good services for more than 10 years. And they had 2 MET payloads, 2-channel VHRR radiometer for imaging Earth cloud cover with these resolutions, and a transponder for collection of data from remote areas. So these 2 capabilities were there. But as I mentioned, this was primarily for 3 services and a Government of India initiative. It was not part of World Weather Program of WMO. This is how it appeared. The INSET 1, the solar boom on one side, panels on the other side, and VHRR imaging for viewing the Earth on this side. The 3-axis stabilized platform. Now many missions of the world are of this type, which we will see in few minutes. And we had a number of derived products from INSET, apart from pictures which we use for day-to-day monitoring of weather system. With these frequent pictures of Earth cloud cover, every half hour or every 1 hour, 2 hours, we did better tracking of the weather system of every type, western disturbance, cyclone, and so on. And a lot of products, cloud motion vectors, standard products, OLR, SST, QPE, and CTT, and so on, they were started deriving from that time. Then second generation INSET, they started from 92. Again, it was for 3-in-1 services. But important thing was, it was indigenous. We changed from foreign procurement to indigenous. It was built by ISRO, and under this program, to start with, we had 5 satellites, but only 3 of them carried MET instrument, 2A, B, and E. C and D didn't carry MET instrument, and from 92 to 1999, we worked with them. Now with better improved resolution of INSET 2 series as compared to INSET 1, we prepared better quality of product, better images, and to 2A, 2B, we had these 2 instruments, VHRR and a transponder for data collection with resolution 2 and 8. But with next INSET 2E, we had 3 channels. We also added water vapor and another new payload, what we call charge coupled device, CCD, with 3 channels for 1 kilometer resolution. A new instrument we added on INSET. But with 2E, our experience was not good, so therefore we had to go for, this is the figure of course, INSET 2. This is the one with MET capability, VHRR on this side, antenna, and these didn't have MET component, so therefore panels on both sides, they were purely for communication and TV, not for MET. These were for MET. Now, the first dedicated MET mission was successfully launched by ISRO on 12 September 2002. It was called MetSet because there was a need for MetSet at that time on a fast track mode, because INSET 2E, which we started at that time in 1999, it was not performing to our satisfaction. So of course it was later renamed as Kalpana INSET. The MetSet, it was a high priority project started in 99. PSLV launched from Sriharikota, and of course 3-channel VHRR imaging radiometer and identical to 2E, but with no payload for communication and TV, just MET. It worked for 10 years. And again, next to MetSet was INSET 3A. It was started in 3rd April 2003. It was identical to 2E because this INSET 3A had been approved prior to MetSet in 98 or 99. So this was available, it continued. So this was the final spacecraft with the communication, TV and MET. Afterward there were no, so this was MetSet only for VHRR, and then of course came the advancement with INSET 3D. In 2013 we started major improvement in imaging instrument, 6-channel imager. Instead of 3, it was 6-channel and improved resolution, 1 in visible, 4 in IR, and a new imaging instrument called atmospheric sounder. This was added with 19 channels and capability of automatic image navigation registration system. This is also very important, as I will show why it is important after some time. Operational, it is working at present. It has worked for 10 years now, and now I think any time it may have to be replaced with a new one, because 10 years is quite big period. So this is 3D. You can see both part sounder and imager, and with no boom on the other side. It is just panel and 3-axis stabilized platform, and optics of just a scan mirror. It gathers radiation from Earth, puts it on the optics, and it goes to different detectors. 4 detectors for IR, 1 for short wave, other for, so 6 detectors they detect through the optical port. So this is the image of 3D. Such images we are receiving on an operational basis coverage. Of course, these are some products, RPG product designed by Dr. Mitra of IMD. He will be talking about these products in his own presentation in this program. And main thing about this data processing system, which is solved at IMD in 2008, then again upgraded in 2016. There's a real-time data analysis of products and information system, what they call RAPID, by which you can have many products, you can see them, use them, and then there are other missions over India. Apart from INSET, there is a Meteor Set 9 mission of IODC under from MSET at 44.5. It's geostationary, and Himawari of Japan. We can view from India. We can receive data over Indian region. I will show its data every 10 minutes scan. It has this also has every 15 minutes. INSET has every 30 minutes, but for some smaller area we can take every 7 minutes sector scan. Now these are the Meteor Set series of satellites. This is the first generation, second generation. We are now receiving data from Meteor Set 9, which is second generation. First generation has ended. Third generation has just started from December 2022. It is very powerful system, multi-channel sound imager and lightning imager, very good instrument. They will start regular operation with this in next few months, and so my forecast is maybe in 10 to 15 years, one such system will be over India. Maybe in 15 years time, this will be over India, because at present we have this one over Indian region, and maybe next few years, once these are not there, second generation are over, third generation will come. So this is the picture from Meteor Set. I am showing this image full frame, and the RPG project, convection project from Meteor Set, and this is a sector over West Middle East, Afghanistan. You can see I took this image on 7th November, so just 2 days back, and this is the site address from which you can get this imagery data every day, real time. You can see image products. See why I am showing it, because one participant from Afghanistan, I think when he answered to the questionnaire which we sent, he mentioned that we were receiving Meteor Set images, but now we are not receiving. So now I think if you see this address and try to get it, I think you will be able to see it. Maybe we can talk to you if he is there, in the, if he is attending. So Meteor Set images can be received in Afghanistan also. There is no difficulty. If you even inset images which I showed, you can see through their website and use it for whatever purpose you want. And this is Himawari 9, Japan. You can see that India is on one fringe. India is here. So just on one fringe, rest is all this Pacific, Japan, and so on. So Bay of Bengal is here. This is India. But in spite of that, we get good coverage over Indian region. So this is one sector, which South Asia sector, Bay of Bengal, we can see, and we can see there heavy rainfall, potential areas of heavy rainfall. This is one of the projects, the convection project, and daytime microphysics project. And one cloud burst event I observed using this Himawari data. I will just show, it was over Himachal Pradesh on 17 July 23, just about a month ago, at 3:55 a.m. and it is 32 degree north, 77 east. I will just show it here. So I request that you may focus your attention on this area, here, okay? Just focus your attention in this area, and I will move the images so that you can see the cloud burst event which developed here. I'm just going forward in time. It is starting from 1900 GMT, and I'm moving forward in time. And you can now see over this area, some cloud has developed here, okay? This is the location of that where it was observed, and I'm moving forward. It is every 10 minutes. And you can see that at one time, at one point, intensity is increasing with time. As I change the frame, intensity is increasing. And at about the time when event was observed, this is the time here. The event was observed at this time. This was the image at that time. So gradually, what I am trying to show is at one focus point, intensity goes on increasing as you change images with time. Every 10 minutes, if you take image, the intensity increases. And important thing is, it is at the same spot, same time, the same place, every 10 minutes.
And it is 30 minutes, exactly 30 minutes.
Okay, thank you. Okay, so with this, afterward, this cloud burst. Now, same thing if I observe on INSAT, it is here. This is Himachal Pradesh. So the event was observed in this way. cloud burst. So hardly anything you can see from inset, whereas with this one you can see every 10 minutes at same spot. But only thing is forecasting is difficult because event is occurring and damage is occurring and you are observing at that time. But I think precisely saying that it will occur at such and such time at such and such spot is difficult as of today. So now why it is important? See, it shows why every 10 minutes or every 5 minutes observations are important. If I don't have more frequent images, I cannot observe such phenomena. And for observing this, image to image registration should be very high. See, if at one time image is focusing at one place, in next 10 minutes also it should show image of same area and so on, third, fourth, fifth. And what I am saying is there should be no shift in the successive images. And channel to channel registration also should be of very good quality, and very stringent specifications are required for image navigation registration system and attitude and orbit control system to achieve this kind of. Now, as I mentioned, the Himawari is on the fringe. See, if you see the image which I showed just now, see, this is 70° east, this line, 70° east, and this is 80° east. This is 30° north, this is 25° north. So beyond this, no image is there. So as you can see, this is on the fringe. In spite of that, it has provided reasonably good quality of data, and I can say that it is the image of the cloud burst which was observed on that day. And approximately from the coordinates which I could see from this image and the coordinates of the place from the internet, I could see that this is the event. I have observed similar events at other places also, which I will show in my next presentations. Now, a number of satellite systems world over, they generate quite a good number of atmospheric, ocean and based products for various applications, and they are disseminated to users for GTS and operational and research. Now, products are SST. You can understand the importance of SST for particularly this phenomena which we see warming over the ocean. This year we are observing, unless you have very high quality observations spread over a big area, you cannot observe such phenomena which are important for monsoon and other general circulation systems. And outgoing long wave radiation is also important. So this shows a mean of outgoing long wave radiation 1979 to 1995 January, because ITCs has shifted southward, so you find small OIR in this area, and in summer it goes small areas are seen here. And of course, this product, outgoing long radiation, is also important because you know that MJ index, which he has worked out, which is useful for seeing the phase of monsoon, is based on outgoing long wave radiation. As you can see from this diagram, it is taken from the research paper. Now, how to use these products? Now, best use of the space-based system is assimilate them in the model, because there are so many products. If you give to forecasters, they will find it difficult to use it unless they have training, and so therefore, because they are quite big in numbers, therefore it is important that you give them through GTS, and they use in their numerical weather prediction model. In fact, more than 95% of meteorological data being assimilated in model, it comes from the space-based systems. And the satellites provide a lot of data to users for scientific research, and studies show a lot of positive impact on the forecast after using this data, and maximum contribution come from MSU and hyperspectral sounders. And because of using space-based system in NWP, the forecasts have improved considerably. And moving.
Sir, slides are perfectly fine.
Huh?
Sir, we can see the slide.
You can see, but I find it is not moving. How is it?
It is not moving. So you click.
Ah,
Yeah,
sir,
now, yeah, it's moving now.
Okay. Okay. Now, as I show here, this is percentage contribution to forecast error reduction from different space-based systems, different instruments. MSU, as you can see, is on top. The maximum contribution comes from MSU, and other than that, it is infrared sounder, ERC, AIRS, AREPS, and of course there are so many other types. So maximum contribution is from MSU. And this is taken from this site. The diagram which I have shown here is taken from this site. And of course, I skip some of the things. Now, using this data of space-based system, we can monitor monsoon. This is total pressure water vapor. As you know, during onset phase, the water vapor increases and it progresses further northwards. It starts, first the onset starts from here, Andaman Sea, and then it gradually progresses. This is on 3rd June this year. And what you can see is already there is some tendency of rotation in the moisture. You can see here. And next day, if you see 4th June, you can see there is more rotation here. So a system has developed in this area, low pressure system, because I can see the rotation and verticity has increased. The Wisconsin is also showing that a system is going to form. Now, if I see the Wisconsin, the 850 HPA verticity, it has increased from 4 to, you see, this is 5th 9 GMT. So verticity has increased, convergence has increased, and it is showing rotation. So therefore, low pressure area is formed. And in fact, this was the system which made Biparjoy in next few days. It moved northwards. And similarly, for weak monsoon condition, we can have good signal in the satellite products. You know, monsoon condition was weak for 13 days in this month, about few days back, and rainfall over the country as a whole is much smaller, but more rains to the mountainous region. And this is the type of moisture distribution which we see in a monsoon break condition. You see more moisture distributed here, and you see here also some moisture because there was a trough from sub-Himalayan West Bengal to northwest Bay of Bengal. So, but you don't see any long build-up of moisture here. The monsoon trough is to the foothills of the Himalayas here, western end, and eastern end also quite north of its normal position. And this is the distribution of moisture in the weak monsoon condition, and this is the cloud system which you see corresponding to this. And again, after 4 days, again you see weak monsoon condition. But what I'm trying to show is heavy rainfall. I will skip the revival of monsoon from 17th onwards after a prolonged break. Now, after a break, you can see that a system is forming here. Low pressure area, a cyclonic circulation is there, and this is an indication that things are going to change. And same thing you see in the products. You see now build up of moisture has started here, but western side is still far away. Here it has started, and you can see winds. This is from Japanese. The winds have turning here, so that means something is forming. Same thing I see here, but important thing is verticity. Verticity has increased in this area. So what it shows is that this is a favorable condition for revival of the monsoon, increase in the verticity. Again, same image of next day. Of course, I did not show this. Now again, from 3rd September onwards, after a prolonged break, from 3rd September there was a conditions for revival of monsoon. So this is 27th, 28th August. Again, break is continuing. There was temporary relief from 17, 18 for some time, but again on it was weak. So this is, you find weak monsoon condition, no moisture here, moisture build up here. 31st also same thing you find. So, but things have started changing now. You can see moisture build up, and what is important is on 2nd October, the 2nd September, sorry, the verticity started increasing in Bay of Bengal. See, before that, if you see, it was mostly anticyclonic verticity, but from 2nd September it started increasing. So this is a signal that things are now going to change, as we saw that on 2nd October, 2nd September, it has changed, and there was formation of a low pressure area over northwest and adjoining west central Bay of Bengal of Odisha and North Andhra Pradesh coast on 5th September. So you can see this here on 5th November, the rotation in the moisture field. So that means a low pressure area has formed here, 5th, which is continuing, and but you find verticity has now increased. 5th 3 GMT, it has increased considerably as compared to past 2 or 3 days, and inside also it has now, which was predominantly anticyclonic, it has now started increasing. It is favorable condition now, and now we have seen this convergence has also increased, winds are also favorable, and we find that it has increased now. It has now revived monsoon. So I skipped some of these things, but
Exactly, it is 45 minutes now, so you can continue, but just keep it.
okay. Okay, I just try to finish off quick. Now, I just want to show one case here, which was sudden development of low pressure system over North Odisha and joining West Bengal coast on 29th July 23 morning. It was not anticipated earlier, and in fact what happened was, there was, prior to 29th, there was a low pressure area here which was moving, and it was going toward Gangetic West Bengal, and we thought that it will dissipate, and there was no forecast for development of low pressure area or depression over Bay of Bengal on 29th. But what happened was suddenly this moisture started increasing in this, and even if you see the verticity product, it was on 28th 6 GMT. It started increasing and it drifting eastward. That is more important. So here on 30th 12 GMT, by the time it has formed suddenly. So therefore, it was visible even on 29th at this position, and we could say that a system has formed, a new system which was not anticipated. And of course, it became a depression. It had affected Bangladesh, and in fact, in Wisconsin product, it was declared even a cyclonic storm, but IMD made it deep depression, and it was not anticipated earlier. But from these products, we could say that something is forming, and it did form, and even in picture signals were there. So these are some of the important things which we can see. You can see here on 28th 18 GMT it was here, and suddenly it has come shifted eastward at 29:0 GMT, and it has again come here by 30th. You can see increased vorticity and withdrawal phase of the monsoon. I will show here just a few slides. You see, withdrawal started from 23rd, 22. I am talking of the year 22 September. 29th, 23rd it started. You can see the dry air, and it has come up to this place. But then what has happened is there is a system forming. There was remnant of a system which came from east. It drifted westward, and then in next few days, on 6th October, you see a surge is there, and the withdrawal of monsoon has stopped. The dry air which was coming here, it has now gone backward, and it is taken over by the weather, moisture, strong monsoon flow, and it has given good rains over north and all central India. In fact, it was a depression which caused good rains over New Delhi on 8th October 22. And once the effect of, after few days, the effect of rains has gone, depression has weakened again. You see, monsoon has started withdrawing here. You can see the dry air has come on 14th. Again, 15th it has come down. 19th it has reached further southward. 20th, 23rd it has withdrawn from the entire country. And it so happened that on the same day, a cyclonic storm also struck Bangladesh. It's very rare, of course. Monsoon withdrawing on this side and cyclonic striking on Bangladesh, West Bengal coast. It's a very rare event, of course. So afterwards, the northeast monsoon didn't start for few days. It started only on 29th. As you can see from this, 27, 28, there was surge of moisture approaching from the east. You can see these clouds forming. The highly moisture approaching from the east, the southern parts of the country. You can see on 29th, this is the day when the northeast monsoon rain started. You can see a very high surge of moisture coming from the east. And once you see this, you can say that rains are going to start, heavy rain going to come over east coast in next 1 or 2 days. So moisture convergence taking place. You can see here the convergence taking place in this area, thunderstorm developing, and the upper level divergence favorable for sustenance of thunderstorms. So you can see this. Okay. So what I do is I go forward fast and then wind up. So this was same thing I was showing Doppler weather radar as the moist air is moving westward. You can see rains approaching Chennai. Okay. I move fast and then go towards for western disturbance and other things I show in the main talk which I have after some time. The important thing which I want to show for western disturbance is that when a western disturbance is approaching northern parts of the country, then at 500 HPA you see the vorticity approaching from Red Sea towards Indian region. This is here. So once you see on this project, you can monitor western disturbances using vorticity and wind products. I'm coming towards end. Just I want to mention that future programs of India. The other day, Dr. Kevkar mentioned about future program of other countries. He mentioned about tropics program, and as far as INSET program is concerned, there will be INSET 3S launch end of 23 or early 24. So then 3D will have to be stocked after 3S is ready. And so 3DR and 3S, 3DR is already up. It is operating from 2016. So 3S, they will provide continuity of 3D like services. And then INSET 4 series of satellite will be more advanced payload around, they will start around 2030 INSET 4 series with more advanced payload. And a task group of IMD as ISRO has mentioned in their report, which is which is being submitted to ISRO, the high resolution multispectral sounder, lightning imager, hyperspectral sounder. So whatever instruments are there in other missions which we have seen before, they will also be incorporated on future INSET 4 missions. Once the program is approved, they will start in our system from 2030 or so. And before that, there is a program to put an experimental satellite called Geostationary Imaging Satellite, GSAT-1, an Indian Earth observation system, which will have a multispectral imager with visible near IR thermal IR images with 0.50 meter resolution. Now, the MET data provided by space-based system is extremely useful for day-to-day operational work of weather forecasting and research-related works, there have been significant development in past 63 years. Now you can get more than 100 type of products you are getting from different systems, and they are being assimilated in NWP models. They are being used properly, and they provide most essential and vital inputs for running NWP model. In fact, without space-based system data, you cannot think of even running NWP model. They are so vital, more than 95% as I mentioned. And they are also useful for modifying NWP, satellite-based products. You can use for modifying NWP. Of course, there are some case studies available on MSET site. I didn't show any one of them, but it is possible you can use Sept products for modifying NWP analysis so that you get better forecasts. And it is useful for monitoring different phases of southwest monsoon. It is useful for nowcasting, better warnings for severe thunderstorms. In fact, in nowcasting, there is one case which is there in my notes, that the cricket match 28th May 2023, this year, IPL final, evening there were severe thunderstorms over Rajasthan and Pakistan. They were moving southwards. They moved toward Gujarat, and by evening they were near to the west of Ahmedabad. So it was known that there will be severe thunderstorm over Ahmedabad on 29th night, and it did happen. And next day, again the match was repeated, and it rained for short while next day, but the match could be completed. It was not so severe as on 29th. So this is possible using Sept products. It provides reliable indication for actual formation of low pressure areas. You just see the moisture pattern, vorticity, convergence, and you can say that a system has formed, our system has weakened by just seeing these things. And it is useful for monitoring cyclonic storms. See, precise monitoring of storm initial condition is possible with INSAT and other satellite-derived products. Much improved weather forecast services to a number of specific users of different of national economy, and very useful for better tracking of western disturbances, which is I find maybe in the next one I will show with specific examples. And what I find is it provides useful signals for expected changes in weather systems, leading to more precise weather forecasts. See, when you expect from say break to normal or normal to break, signals are present in the data provided by space-based system, and animated sequences of images and projects are extremely useful for real-time applications. In fact, animated sequences of products are available on the Wisconsin products 5 days. You can see them, verticity product, convergence, divergence, and shear product. But for winds, there are no sequences of images, but you can prepare on your own if you want to study. But I find wind sequences are very useful for seeing the formation of troughs and ridges in western disturbances, which I will show with specific examples in my next presentation. Okay, I think with this it's over.
Thanks a lot, sir. We have learned a lot of things about meteorology through satellite science, which was really unknown for a long time before that satellite came into the picture. So your wholehearted contribution to this field over India is a very commendable things. Now I would like to invite Dr. Rohini Bhawar and Dr. Lakshmi Kumar for the question answer sessions. So Rohini, you start.
Yes.
I think.
Thank you, Dr. Swarup.
Sir, Bhatia sir, please you close that your PPT, then it may work better.
Okay.
Thank you, sir, for such a nice lecture. There are a few questions I would like to address one by one. Where can I download real-time temperature data from satellite? This is a question asked by Sukrani Mitro.
Can you repeat the question?
Where can I download real-time temperature data from satellite?
Okay.
She wants to know where real-time temperature data, from where we can download.
Just one. Actually, if you see IMD website, you can see the CTT temperature data, cloud top temperature. You can observe there, and I think you can even download the image. It's possible. I have been doing it. It's possible in real time. You can see it.
Okay, I hope she must have got the answer.
I
Another
don't-
question by Anil Verma. Since we can find the type of cloud from satellite imagery, but can we also find vertical height of cloud too? If yes, kindly mention some methods.
Vertical height. Now, you can observe cloud top temperature. Okay, temperature can be seen from the data.
Rohini,
Yeah.
I think we did a mistake. So before doing the question and answer session, we need to do that photo session, which I was accidentally missed it. So
Okay.
all the panelists, please switch on your camera for a moment.
Okay.
And expert Dr. Mohan, and now I also request Dr. Paulomi to do some screenshot. But still, I think Dr. Dibba Prakash, Nasim Muradi sir, Tyagi sir, Lakshmi may not be able to do the camera on, which he has already notified. Namanshu sir is there. Namanshu sir, can you switch on your camera?
Tyagi Saab also. Tyagi Saab, great singer.
Tyagi sir is the only left now.
Nasim Muradi and Tyagi Saab.
Yeah. So should we do the click now? Because if
Whatever
they are,
available, you can do now.
yeah. So okay. So I think we have done that. So now again go back to Rohini. So you can continue.
Yeah. Sir, so Anil Verma had a question about how, since we can find the type of cloud from satellite imagery, can we also find the vertical height of cloud? If yes, can you mention some methods? That is what he wants to ask.
You can say that if you find temperature cloud top, and then using the vertical temperature profile, from the temperature you can say this is the height using the temperature profile of the obtained from radio sound or from the sounder. You can get idea of the cloud top height. In fact, that is a method used for assigning height to the clouds in the CMV's derivation scheme or water vapor derivation scheme. Okay.
Yes. Okay. Another question from Anonymous and Mr. Sai. Can you please explain why the satellite rainfall products are unsatisfactory in capturing the heavy rainfall events in terms of sensor saturation?
In terms of what?
Sensor saturation.
Rainfall products are unsatisfactory.
In capturing the heavy rainfall events.
Actually, there are two techniques. One is infrared based and other is microwave. Now, infrared based techniques are indirect. Indirect in the sense that they are dependent on temperature threshold. The temperature, if you see in the infrared, and if they are above certain threshold, you call it rain. But if you want better rainfall product, you have to use microwave. Microwave is the direct interaction of the radiation with the hydrometeors. So microwave gives better products, rainfall. But infrared based, there are limitations.
Okay. Another question by Etini Umukiza. She has actually two questions. When one is interested to carry an observation from past 50 years, which satellite to rely on? That is the first question.
Which
satellite to rely on?
For
what?
The
past 50 years.
For what? Actually, if you see track record, I think I would say that NOAA has a very good track record. NOAA is the system you can use because they are every few years they are intercalibrating and they are improving their products based on the past data, research with the past data, and they also have a program to reprocess data with new algorithms. So NOAA is what they call Pathfinder data set, NOAA Pathfinder. And if you have heard of a TRIM program, TRIM data is also very good. They have many websites over which you can get their data, rainfall estimation, average, and variation over different areas. And you can go to their site and get the data. TRIM is also a good data set.
Okay.
But it depends on the use you are referring to, what kind of use you want to make.
Okay. Another question by the same person. Is it accurate to use in one analysis different source of the satellite images based on time of analysis? NASA combined with Sentinel, for example, to conduct some analysis. So multi-satellite especially, she wants to say.
Yes.
Dr. Lakshmi, do you want to continue?
Before that, I would like to mention, one of the panelists wanted to ask something. Mr. Nasim Muradi sir, you can ask directly to Bhatia sir, because first time we received some questions from the panelists.
Okay.
Yeah.
Please switch on your videos, Mr. Muradi. We have not seen you today. Mr. Nasim Muradi, please switch on your video.
Yeah, can you hear me, sir?
Yes.
We can hear you, but we can't see
Yeah,
you.
good afternoon, colleagues from Sama. Thank you so
Yeah,
much for
yeah,
organizing.
We are visible, yes.
Thank you so much for organizing the meeting. It is a nice program for our staff and for South Asian countries. Thank you so much. I have one question also. We have data gaps in our departments. How to fill the data gaps? Can you help us to fill our data?
How to fill what kind of data gap?
We have data filling from precipitation and also temperature from 10 years.
Is it related to satellite meteorology, Mr. Muradi?
No, it is, we have data gaps actually from ground station.
But that is a general question, not related to.
Okay, okay, then
This is
we
my
can.
question, how to fill from satellite. We
No,
can
if there are data
say-
gaps in your area, maybe you can use satellite images and data products to see the weather. Okay, because if you don't have data, you cannot analyze the charts, as I think so. Temperature, you said there's a data gap, and maybe you have problem in analysis of charts. Is that correct?
How can I find it?
What exactly?
how can yeah, how can I find it?
How can you find what?
The data came.
The data gaps.
No, data gaps are there. In those areas, make use of the space-based system images. Say InSat image or Meteor Set image. They will be there over your area. You can make use of the images for giving the forecast. That is possible, is it?
Yeah, just we can focus. Yeah,
Past years.
we need the past year's data.
Which data?
Past year's data.
Past data. Okay.
Yeah.
Past data, go to the website of the, I think there will be presentation from MSET. MSET, they will be giving a presentation on how to access past data from their website.
Yes,
In,
sir.
this course.
Yeah, thank you so much.
They will be giving.
Okay, thank you, Muradi
any-
sir. Yeah. So, Rohini, you can continue, or Lakshmi, you can continue.
Okay, I will start till Lakshmi comes. Another question by Dr. Mohammad Rafiq. Thanks for the information about the modern day satellite data for meteorological research. My question is regarding the snowstorms prediction. Are there any data sets available for snowfall estimates?
Yes, I think the data sets from MODIS and this Aqua series of satellites, they will be able to give you snowfall data. MODIS,
Okay, sir.
Aqua, Terra, it will be possible to have data sourced from them.
Another question by Raihan Ahmad Khan. When anomalies are encountered and forecast is found unable to predict such phenomena quite often, what is the approach that is used or which we can use to improve the mathematical model?
See, when you find that sometime you don't anticipate something and that happens, so best thing is that you go back to your numerical weather prediction model and see why it could not predict some situation. Maybe see what happens. Numerical weather prediction models, sometimes there are errors in that, even in spite of so many improvements and a lot of research that has been done in NWP. At times there are errors, and at certain time there are quite good number of errors, and more errors. So therefore, I think it is important for a forecaster to be able to assess how NWP has performed, whether it is guiding me properly or is it misguiding me. He should not be misguided by NWP. So there are methods actually by which you can correct NWP using data from space-based system, particularly water vapor imagery. There are methods. If you go to the website of MSET, Comet, they have explained 2 or 3 cases in which this can be done. They have shown with examples how to do it, how to correct NWP using information from space-based system data products. 3 or 4 cases I have seen myself. So it depends how we are using it on an operational basis. If you see them and try to incorporate in your day-to-day thing.
Okay, sir. Another question by Nirvan Abhilash. How satellites detect, track, and monitor thunderstorms?
How satellite detect what?
Detect, track, and monitor thunderstorms.
Oh, thunderstorm. Okay.
Another one. Also, what derived data or parameters we should use to have spatial map of thunderstorm distribution?
The thunderstorm can be detected with visible infrared images. Visible and infrared images. If you see the visible infrared images, frequent images, every half hour, you find white areas, the white areas and sharp areas. So those are the areas where thunderstorms will be there. So I think visible IR images are the best source, and frequent images, how the thunderstorm, how the clouds are changing with time, with how the temperatures are changing. If the temperature is decreasing with time, that means it is growing. Temperature is reducing with time, that means it is dissipating. And also in successive images of visible and IR, you can see what is known as convective scale interactions. That means there is a arc boundary coming out from a thunderstorm, and that is moving out, and when it encounters another cumulus field, then it interacts and generates more thunderstorm. So this you can see every 10-minute images with maybe with Himawari 9, you see thunderstorm season. Every 10 minutes you can see them, monitor them. And even with INSET you can see.
Another question by Dr. Mahesh. Can we make flood risk map by QGIS by DEM? If yes, which data will be useful for that? Flood risk map.
I think I have seen one paper by some scientist, I don't remember his name, in MOSM, where he has used SMOS data, SMOS, SMOS data for monitoring floods. He has a paper. But I think for monitoring this type, you need other type of data, not MET data. Maybe sometime if there are clouds over the floody areas, you cannot monitor. So therefore you have to use data from other sources. Say, I think ISRO is monitoring using their system, and they are also providing maps of flooded areas. So I think better use their products rather than this INSET and
So Rohini, now Lakshmi wants to ask.
Lakshmi.
Sir, good evening, sir. It's a very good lecture. Sir, my question, it is related to aerosol optical depth by the satellites. So we know that the aerosols are different sizes of aerosols are sensitive to different wavelengths. Suppose if you take the MODIS gives the aerosol optical depth at, let us say, UV and visible wavelength regions. So by using this derived AOD from this UV and visible regions, by using some empirical methods, we can estimate AOD in infrared regions also. So how far these methods are reliable?
I think better data for aerosols would be MODIS, not this infrared visible, which we get from INSET. So MODIS, and I think you can use other systems, CRISPO and maybe CloudSet for aerosol, not this INSET.
Yeah, actually, what my question is, suppose we have AOD at certain wavelength, and I want to estimate using that AOD of that wavelength to the AOD for different wavelength, something like that. Like you can say AOD or angstrom exponent.
Yeah, I could try.
Yeah.
If you have 2 angstrom exponent, we could extrapolate to the higher wavelength. But still, there is a little bias, but it's still worth to get the trend.
To get the reliability of the method.
See, we are working on it. I mean, a lot of people are using that formula, so I think it's quite stable.
I don't think we can use INSET, but I don't think. I'm not sure about it.
Okay.
So actually, Lakshmi, I third, also you need to you will ask question on behalf of other participants. So
Yeah, please.
if
Yeah,
you
I'll
are
check.
not,
Yeah.
then I think Rohini can continue.
Yeah, I'll do that. Yeah, I'll try to pick up relevant questions of this lecture.
Or if Rohini, if there is no more questions, we can go for the concluding the session.
No, one. I want to ask one from YouTube.
Yeah, actually,
Okay.
the question is, so what is the method of finding vertical height of the cloud from satellites?
Already asked.
Okay.
Can
Okay,
I?
Rohini,
Yeah.
I think
One YouTube question, one person, Abhishek Anand, has posted a question. Can we locate Somali jet from satellite data or imagery? If possible, then what band, IR, water vapor, or SWIR?
For
just out of
that, I
curiosity,
think
Abhishek Anand from IMD.
yeah,
Abhishek, oh.
for that you can use insect derived winds. Insect derived winds can be used for finding the location of Somali jet. The insect derived CMVs, they show the speed and direction in the monsoon season, and sometimes we see that winds of the order of 50 knots near Somali coast. That is possible. It can be seen from CMVs.
Another one from Murali Krishna. Sir, is it possible to merge the all satellite radiance data in a single quality check data set for data assimilation? Since now all data sets are different, like AMSU, INSAT, and etc.
I couldn't understand.
Sir, he wants to know if it is possible to merge all satellite radiance data in a single quality check data set for data assimilation purpose
Okay.
from different satellites.
No, actually, you see, if you want to assimilate radiance data in NWP products, in NWP models, there are some checks possible in the assimilation scheme itself. If it meets certain standards, it is used. If it doesn't meet certain standard, it is not used for assimilation. There are a lot of quality checks done in the assimilation scheme itself. Okay. It's I think question is more for the assimilation, the person who assimilate data.
Swagata, can we take two more?
Yeah, you can take. Yeah.
Okay.
But before that, I would like to announce one thing. Around 334 people joined through Zoom. They have registered, and apart from YouTube members, around 25. So around 400, we could say, they have attended today's lecture.
Okay.
Yeah, you continue.
Okay, one anonymous attendee has asked, is it possible to predict cloud bursts? What are the methodologies?
Yeah, prediction, I don't think it is possible precisely, but you see, when you say prediction, you want at what point and at what time. That is that is more important. If I say generally there will be cloud bursts in this area, if I point out a big area, that's of no use. But in the big area, where exactly? So I think the way forward should be through, I think, developments in the numerical weather prediction, more precise high resolution models covering mountainous area. If you can develop that and have better prediction in the, say, if you can simulate them, if you can simulate actual conditions which have occurred, if you can at least simulate them, and then you can predict. Maybe I think Dr. Sumeshwar Das, he is more experienced, he can talk about it.
Okay. So there is a question from a student from SUST named Sanjit Chaudhary Tanmay. Are there any obstacles or difficulties associated with satellite-based data collection from cloud cover?
Satellite data collection
from cloud cover.
Due to the presence of cloud cover.
I think so. It should be like
Yeah,
that.
due to the presence
The
of cloud.
presence of cloud cover. Okay, okay. No, I think I don't think there are any problem. You can collect data even if there are clouds. There's no
Yeah,
difficulty. I don't
depends
think so.
upon the wavelength range.
Okay.
Sir,
I
and
think
just
Rohini,
last
yes,
one.
yeah.
And then you answered about the snowfall, like you can take from Modi's data, right? So he just wanted to know if we can differentiate between liquid and solid precipitation also from that data set.
Yes, microwave are better suited for that. For solid, you can make use of high frequency bands in the microwave. It is more suited for, say, 85 gigahertz. It is actually it will give indication about scattering. 85 gigahertz. It shows scattering from the ice particles. So it can be used for better delineation of liquid and solid.
Okay,
And there
Rohini.
are other channels.
Yes. Yes.
Okay,
sir.
Rohini, thank you. So before concluding the today's lecture, I would also like to mention the next lecture will be related to the principle of remote sensing, which is the basic of understanding of the remote sensing. So all the participants, I would like to mention, without going through that presentation, the rest of the lecture would be more tougher. So please be there on next weekend, 3 to 5. And now I would like to invite Dr. Mohan Kumar Das from the director NOAMI and also Joint Secretary of SAMA for the vote of thanks.
Thank you, Dr. Shagata Bhatia. Good evening. We wish to express our sincere gratitude to all attendees for their invaluable contributions, which have played a pivotal role in making the session on overview of satellite meteorology and its applications a tremendous success. We extend our warmest appreciation to our distinguished speaker for the evening, Sri Dr. Ramesh Chandra Bhatia sir. Guiding light. Sri Dr. Ramesh Chandra Bhatia has emerged as a guiding light in the field of satellite meteorology and its applications. His extensive knowledge and expertise have illuminated the path to a deeper understanding of this critical domain. Esteemed authority. Dr. Bhatia's distinguished career and unwavering commitment to meteorology have rightly established him as an esteemed authority in this field. His insights and contribution have significantly advanced our understanding and application of satellite-based meteorological techniques. Appreciation for the speaker. We extend our heartfelt appreciation to Dr. Bhatia for generously sharing his expertise with us. His insights and perspective have enriched our knowledge and will undoubtedly inspire further advancement in satellite meteorology. Gratitude to organizers. We would also like to express our gratitude to the event organizer for their meticulous planning and dedication, which have made this session possible. Their effort have provided us with a valuable platform for learning and collaboration. Charting our course. As we reflect on this enlightening session, we are inspired by Dr. Bhatia's wisdom and the collective spirit of exploration that has prevailed. Together, we look ahead to a future where satellite meteorology continues to drive progress and innovation in weather forecasting and environmental monitoring with deep appreciation. Thank you.
Thank you, Dr. Mohan. So let's conclude the session for today. We will again meet on next Saturday, 3 o'clock.
Thank you.
Maybe Tyagi Saab would like to say something. Last word. Tyagi Saab is there or not? Yeah, he's there. We missed you in the photo session. We missed you, sir. Maybe you can have once again the photo session, and now maybe everybody is there. I can see Dr. Kya also.
Yeah. So all the panelists switch on the camera.
This is for final photograph.
I hope so. Nasim Muradi sir, last time also you were absent.
Yeah, he missed last time.
Yeah.
So,
So,
and Navanshu sir.
Navanshu.
And Kelkar sir. and Dr. Kyomo O from Myanmar.
Dr.
Yes.
Moy O.
Yeah, from Myanmar.
I think,
Okay, now you go ahead.
yeah, Mohan. Yeah, I think it has been completed because I noticed that Mohan's
I
eye
think
was,
done.
going
Yeah,
down
no,
and
no,
up,
Dr.
going up and down.
Okay,
Kimo is
Dr.
also
Kamo available.
Yeah, okay, yeah. So Namansu sir,
And Navansh sir,
yeah,
one
sir,
time
for a
please.
moment, Namansu.
yes.
Perfect.
Perfect. Okay. So let's say bye and thanks to everyone for making the successful event. We'll again meet on next coming.
Thanks. I would like to say some closing words.
Oh yeah, okay.
Yeah. Well, it was very, I think, as an introductory talk, covered all aspects. Now, my request for the following lectures would be if you could get one-page summary of these lectures, which will help us to bring out some executive summary or compendium of the lecture series, and also request speakers to give some 10-20
questions
so that when you are
we are going to
evaluate them, and so these two things could be so you could write to the speakers well in advance also, and those who have already delivered talks, we can request them to provide these. And
right.
Yeah, thank you, sir. Second thing is also we should bring down or help the speakers by getting their presentation, which can be loaded from our side, and also to draw a SOP, which helps the speaker to load his presentation and share it. So, so these two things, if are done, we don't face these glitches every time.
Dr. Swagata,
Thank you.
I thought to just add a few points, based upon the questions that many participants had asked. Okay, just a few minutes. I thought I can try to add up that.
Yeah, for the simulation part especially. Yes.
I mean, there are many participants ask questions regarding forecasting of the snow, or distinguishing between snow and rainfall forecasting, or cloud burst forecasting, or simulation, etc., or data gap region for that matter, which Mr. Muradi also asked. Now, you should understand that all these things are not directly related to the topic of satellite meteorology. Many things are the subject of NWP, because satellite, whether satellite or radar or any instrumentation for that matter, that is just a tool for observation, current observation. What is the current state of atmosphere, right? It only gives that. It doesn't tell you about the forecasting, except that you can just extrapolate the past 3 hour data and then say that the system is moving in this direction or that direction. The main thing is that you have to have a NWP model to be able to forecast whatever you want to forecast. Satellite is one of the models. Satellite data is simulated in the model, and then accordingly the model gives you the deterministic forecast for the future. Also, regarding the assimilation, various types of satellite data, I mean, somebody was asking whether we can assimilate different types of radiance data in the satellite. Yes, it is already going on the day-to-day basis. And centers like MC, WF, IMD, even at IITM also, different kinds of satellite data are assimilated already on a daily basis. So it's an ongoing thing. How it is assimilated, that is a very big subject. I mean, data assimilation itself is a full semester course. It can be just explained into 1 or 2 minutes. So you have to learn about the data assimilation part, and especially the satellite data assimilation. I mean, there are different operators used for assimilating different types of data. Like to assimilate radar data, there is a different operator. To assimilate satellite data, there is a different operator. Similarly, to assimilate the radio sounds and vertical profiles, etc., there are different operators used for that. Okay, so that is a vast subject in itself, and that is nothing to do with the satellite meteorology is one of the part, but it is an independent subject that you should know. Regarding the data gap, again, what kind of data gap? Whether you are looking for an image, satellite image, or data gap of the temperature, etc., etc. Data gaps you can't fill up. You can't think of filling up using the satellite alone. And for that, filling up the data gap, suppose some station in Afghanistan is missing, or so many years of data is missing from some instrumentation or some station from Afghanistan. For that, I think better you should go for the reanalysis data. Just use this reanalysis data. I mean, there are so many reanalysis data. NSET reanalysis data is there. ERA is there. Nowadays, IMD AA is there, which is much higher resolution reanalysis data. So use the reanalysis data for the past 50 years. And then you can just extrapolate the station where you are looking at. That is, I mean, best way you can get it, because reanalysis is made for that only. I mean, somebody was asking about the satellite data 50 years ago. By the way, the first weather satellite itself was launched in the 80s. So, I mean, how can you expect getting satellite data 50 years ago, right? And you can imagine the initial satellites were not that much developed, right? Like the current satellites. So the Tyrus, etc., which were supposed to be the first weather satellites, they were launched in early 80s. They will give you only basic things, not the high-profile vertical sounders, things like that. Okay. So these are the things I thought I should clarify. And participants, I'm really glad that you are all attentive and asking different types of questions. You can still ask questions through the email also. Some questions were not addressed because of the lack of time. You can send an email, send your question by email, and we shall try to answer that. Okay, so that's all. And many people are asking about the PDF of the lectures, etc. So those things will be, I mean, we shall try to make them available. Of course, that depends on the speaker. We are requesting the speakers to provide the PDF or at least one-page summary of their lecture, which we can share with all the participants. But in any case, all the lectures, the video recording of the lectures are available on the YouTube and will be available on the YouTube. So you can go back anytime on the YouTube channel of Sama and then have a look at that. Okay, so I thought to supplement these things. Thank you, Dr. Swagata.
Yeah, so thank you, sir. So let's we close the program because it's more than 2 hours now. Half of the participants had already left. So bye. Thanks.
Bye.
See you again on coming Saturday.
Bye.
Okay, sir.
Hello, bye.
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 How are you?